This problem deals with two slits, a double slit situation, which I'm drawing here. We know from the problem description that the separation of those two slits D is equal to 100 times the wavelength of the light that comes in. So we imagine wavefronts coming in parallel. So we have a Fraunhofer situation, also possibly a screen far away. That will become important in the second part of the problem. So a Fraunhofer diffraction phenomenon. And in this kind of situation, this could be the wavelength lambda, we then have a central maximum on our screen, which I might draw like this. This is the central maximum, and then not much reduced further maxima on either side. So there's one here and there's another one there. And the problem asks us to work out what the angle is between the zero maximum or the central maximum. Sometimes we refer to it as the zeroth, sometimes we refer to it as the central maximum, and this would be the first maximum. And the first order maximum, or the primary maximum. And we're interested in this angle theta here. Now, in order to solve this problem, we need to realize that we have a double slit, and we're looking for constructive interference. The condition for that is given as D, which is the D up here, the separation of the slits, times the sine theta equal to m, whereby m is an integer running from 0 to infinity, times the wavelength. So whenever we've got multiple wavelengths path differences between the ray that comes from this slit and the ray that comes from the other slit ending up here, we will have constructive interference. Since the angle theta is rather small, we can also make the approximation sine theta is approximately equal to theta in radians. That simplifies the equation, and we can isolate theta as being given by lambda divided by d, since we're dealing here with the first order maximum. We just have m equals 1, and we also know that d is 100 times lambda, so our equation becomes lambda on 100 lambda, and that's equal to 0.01. That's the first question of our problem answered. What is the angular separation in radians between the zero order maximum and an adjacent maximum? And that angle in radians is given by 0.01 radians. And so on this side we would have plus 0.01 radians, and on the other side, where we have the equivalent maximum, we would have minus theta equals 0.01 minus 0.01 radians. The second part of the problem wants to let us work out, in the second part of the problem we need to work out what the separation is on the screen in terms of length, in terms of distance. So this y, what is this y? And we know that the screen is far away, relatively far away, because we have Fraunhofer diffraction, and in fact it's 50 centimeters away, or 0.5 meters. So therefore the tangents theta is approximately the sine theta, and it can also be approximated as y on L. This is the L, the distance of the screen, and therefore the y, which is what we want to work out, is equal to 0.01 rad times 0.5 meters, which turns out to be equal to 5 millimeters. So the second part of the problem has a solution of 5 millimeters, and the first part of the problem has the solution 0.01 radians.